All right, everybody. There we go. How's it going today? Thank you for joining. My name is Mark Dunnekoven. You can hit me up on social at MarkNCA. Obviously, you've already figured that out because you're here on the stream on LinkedIn or on Twitter. This is the final one in a series of streams that I've been doing leading up to AWS reInvent. Final one simply because AWS reInvent is 4 days away. 4. That's crazy. My schedule has been all over the map as it gets busier and busier and busier leading up to reInvent. So today we're going to cover the basics of AWS machine learning. We're going to look at a few of the services. We're going to see how the services are structured. And then we are going to see a couple examples. And then I'll give you a few tips for reInvent if you're coming, and a few tips if you're not coming, actually, because there's a lot you can do even if you aren't in Vegas next week for AWS reInvent. So let's dive in right away. Let me share out Chrome, this one. All right, so we've done a bunch of these already. If you want, I popped the link already in the LinkedIn Live comments. Basically on my site, markn.ca, the main pinned post is this one on reInvent, and you can see all the previous streams. So if you scroll down, you're going to see my guide to reInvent. You're going to see the practical security session guide I did, also the talks I'm giving at reInvent, and then all of the different streams. So you can see the last one we did was on compute. So you can go there. You can also see the transcript. And actually the transcript, the reason why I wanted to show this, the transcript is something that you're going to see the service that we can use to do that with audio or video today. So I think that makes a lot of sense. Hopefully it does. So bottom line, check out that link if you want to see the previous stuff. Today we're going to tackle machine learning, which I think easily sums up with this slide. So if you have any questions as we're going through, hit me up here on LinkedIn or on Twitter, and I will respond in kind. I find it's always best to answer questions as we're going, as opposed to queuing them up at the end. So just ping it in the chat there, and we'll dive in. I've already seen some great questions from folks already this morning. I'm trying to answer as we go or as we were leading up. But here we are. We're looking at all of the services that AWS labels as machine learning services. Now, there's one that's not on here that's actually been retired unless you already have an account and are using it. You can no longer use it, and that was actually called, wait for it, AWS Machine Learning. Horrible name. I don't know why they picked it in the beginning. I mean, I know why they picked it because it made perfect sense, but that service is actually being retired. If you have used it on an account already, you can still access it, but new accounts can't. So I left it off there because, as you can see, there's already a crazy amount of machine learning services. So we're going to start from the transactional services. Now, there's the most of these services. Now, these are just my categories because I find this is the best way to think about machine learning on AWS. Now, if you want to know my credentials, I'm part of the IEEE, International Electronics and Electrical Engineers Association. As part of that, I've been part of the community for computational intelligence for the last 12 or 13 years or so. I've really enjoyed machine learning, AI subsets, all these different areas. It's been a passion and a hobby of mine for a while, so I love that it's gaining really big sort of mainstream attention now. So I know a lot what's gone into a lot of this stuff, and today we're just going to kind of go over and show you how you can start to get started. So you're most of the time are going to get started with these transactional services, and the reason why I call them transactional is because you don't need to build up any models. You don't need to have any of the underlying stuff that makes any of this work. They are simply, you give the service something, the service returns results to you. So we've got Transcribe and Transcribe right off the bat. I'll just go one by one. It's easier. So Transcribe takes audio, gives you back text. Translate takes one language, gives you back another. Comprehend does natural language processing, which is a subset of machine learning where it looks at how language is structured. So you give Amazon Comprehend a set of text, and it's going to give you back the structure of that text. It's going to identify verbs, nouns. It's going to give you the semantics of that text. It's going to give you topic modeling. I actually did a course on this service for Pluralsight. It's really, really interesting, but if you're not a language nerd, if you're not trying to break down what text means, that it's not super useful, but it's still very, very interesting. Amazon Textract is actually a good name. It's a portmanteau of text and extract. So you give this an image or a PDF, and it's going to actually pull out text. Very, very cool. And Lee, I see your comment there on pen testing, machine learning for automation. There is actually some really cool stuff you can do tied to machine learning, and some of these services may pay off for you. But specifically for pen testing, one of the absolute best areas of study, Lee, is fuzzy logic. So fuzzy logic, you're going to see that in fuzzers, which basically goes, hey, algorithm, figure out a whole bunch of weird inputs and throw them against something and see what happens. And that's actually a subset of machine learning, which is under the bigger umbrella of AI. So Textract, like I said, give it an image, give it a PDF. It'll give you back some text information. I did a video when that launched. Actually, I'll link that in the chat, because that was super useful and actually very, very cool. Textract. I cannot spell Textract to save my life, which is ridiculous. But here you go. So this is that video for Textract, Amazon Textract. While we're doing that, I just wanted to call out something that was really interesting, and I misspelled Textract in the thing, but you get the deal. If you're wondering why some of these are Amazon, some of them are AWS, Corey Quinn actually called this out the other day because not a lot of people know it. Amazon services tend to be able to be used on their own. AWS prefixed services mean that you need to, they're a building block, right? So you can see all these transactional ones are Amazon. So Textract, give it an image, give it a PDF, get back text. Forecast, you give it a bunch of data and it's going to do predictions. It's going to do extrapolations out. So this is great if you have a bunch of like sales information. You can do it and say, hey, here's all the sales transactions for 2019. What does 2020 look like? Same with actually interesting, back to Lee's comment around pen testing and machine learning. Forecast is really cool if you shove a whole bunch of network transactional data into it as far as source and destination to see where it's going to forecast network patterns in the future. Very cool. Could probably do a whole nother stream on that. Lex is actually the basis for Alexa. It is a chatbot service. Recognition is the one that you've seen, unfortunately, in the news quite a bit. It's the facial recognition. It's not just facial recognition. It's actually image processing and image recognition. We're going to dive into that a little bit. Amazon Personalize is a personalization recommendation engine. So you can give it a whole bunch of buying habits and it's going to say people who bought this also bought that. So it powers Amazon.com's recommendation system, which is kind of cool. And then Amazon Polly is the last one. Think Polly want a cracker. You give it text, it gives you voice. And you can pick which voice you want, which is kind of cool. So those are the transactional services. We're going to dive into a couple of those in a second because they're really great for demos. And we'll take up most of the time today, I think, doing those demos. But then I wanted to call out some of the ones that you're probably not ready for yet. And I think it's good just to know that they exist. Most of the time, if you're just starting with machine learning, you are going to be diving into these transactional services. But there are these building block services. So there is an AMI for EC2 that's an Amazon Machine Image. And that is preloaded with a bunch of software that helps you run machine learning models. So if you're going to try to run your own models and build out your own machine learning system, start with the AWS Deep Learning AMI. That is managed by AWS. They keep the versions current, and basically once you deploy that server, it's pre-installed with a whole bunch of stuff, which is great. One of those things it's pre-installed with, which is Apache MXNet, which is a machine learning library that lets you do a whole bunch of cool stuff. Amazon or AWS actually maintains that. They're the leaders on that project. And then they also keep a fork of TensorFlow as well. These two things, if you don't know what they are, don't worry about it. They are the libraries that power some of those transactional services. But if you want to go down a level and get into the nuts and bolts, like I said, these are building blocks. Amazon Elastic Inference is a GPU acceleration service. Now what that means, a GPU is a graphics processing unit. Your computer that you're working on right now has a CPU and a GPU. The CPU is the central processing unit. It's a generic thinking machine, right? It's a generic processor where it'll just go through functions and process computations. GPU is designed around graphics, but it turns out by building all these graphics processors over the years, we actually optimize them for a different type of math. That math lines up very, very nicely with machine learning, and Amazon Elastic Inference lets you take a graphics processing unit and attach it to your normal servers, not to run graphics, not to run games or things like that, but to do the type of math that we need to do in machine learning. So it'll basically lowers the cost of your machine learning and makes it faster. So building blocks, really cool if you need to build them out, but if you want to go deeper than the transactional, you go into these partially managed, which is essentially one service, Amazon SageMaker. Very, very cool. It's a level of set of containers that you set up a Jupyter notebook, which is a data science notebook. It's basically a mix of Python code and data, and some other code can be in there too, but normally defaults to Python. And then SageMaker takes care of all the infrastructure to spin up a container fleet to run through all of this stuff and give you these models. So if you have something where you're doing design work and you go like, I don't know what the best shape of a phone is, it's this, by the way, though the new folding phone's super cool. You can run it through SageMaker and run like 1,000 concurrent models, and it will come back and say, hey, here's the crazy new shape that the computer came up with. So very cool if you're kind of getting past the transactional services and want to do more. SageMaker Ground Truth is actually a labeling service where it uses both machine learning and humans to label data. So it's setting a ground truth. The interesting thing is anytime you're using machine learning, if you're in the building blocks or partially managed, you have to create a data set to train the machine to learn on, basically, right? You're creating a curriculum for the learning. So you need a whole bunch of images that are labeled in order to make an image processing service or a transactional image service, right? So SageMaker Ground Truth helps you farm that work out and say, hey, what are all these pictures of? Or can you make sure that all these numbers or credit card numbers are formatted the correct way? Don't use credit card numbers, but that was just the first thing. Security guy, first thing that came to my mind. If you go, okay, I want all these phone numbers formatted the same way, or I want all these, whatever, cleaned up and smoothed out, Ground Truth's the way to go. And then finally, we have 2 tutorial services. Now, these are really, really clever services. AWS built these to teach you different machine learning techniques. And the way they did that was they attached it to hardware. So this is actually a deep lens camera, so you can check that out. It's essentially a normal webcam with a little computer attached to it, right? So it's super clunky. But the interesting thing is that this actually runs a machine learning model on it. So we'll see that in a second when we do a demo of recognition. But this is a way where you could set this up and it will actually recognize things and label parts of the image and say like, this is Mark's, this is a human's head, right? This is a webcam, that kind of stuff. So they did this. They also did Deep Racer, which is a car. It's a remote control car where you don't remotely control it. It controls itself. Now, this was a simple training model that they built to show you how to build models for image recognition. Deep Racer is all about, I'm blanking on the term, but it's another way of teaching you a different type of machine learning. Of course, I gotta Google that. It is, come on. Yes, reinforcement learning, sorry. Reinforcement learning. So that basically tells you, you give the Deep Racer model a set of parameters and say, I want you to value turning, being faster to the next waypoint versus being more accurate. And again, it's a fun way to do it. In fact, it's so fun that there is the AWS Deep Racer League finals coming up next week in Las Vegas. Very, very cool. So that's an overview of how the machine learning services break down. For the vast majority of us, we are going to stick in the transactional services. And the reason for that is that we don't have to worry about the model. We don't have to worry about the training data. We are just getting results. So let's flip over and see how that works right now. So we are in Amazon Recognition. Now this is the one, like I said, where this is actually capable of doing facial recognition. So it's capable of saying, I see Mark in this photo. Right? I see Lee in this photo. I see, Mina in this photo. It's capable of doing that if you give it the appropriate photos with the labels. But what you can see right out of the gate is with their sample image, you can see the results on the right-hand side here. It's 98%, 0.8% confident that it's found an automobile, that there's transportation here, that's a car. And if you actually go on the little boxes, it will tell you where the AI thought it found something. So here it thinks it found a skateboard, and of course it did. But that's just a default training image or default demo image. We're actually going to give it some images from Unsplash. So I found a couple of these images. So we're going to use this one. This is a great photo from Andrew Petrushev, where it's got a singer out into an audience and a few other things. So we're going to take this photo and drop it into the demo. So if we drag this in here, it's going to take a second. And let's see what it comes up with. So now it's processed these results, and it gives us our results on the side here, as well as a confidence rating, right? So now the confidence rating, the 99.6%, is how confident the service is that this is what's actually in the image. You'll notice it's not 100% because it's not sure, but based on the modeling, this is a really high confidence level. And that's actually part of the challenges around the facial recognition and why this service, there was a lot of, and don't get me wrong, facial recognition is an absolutely critical thing that we need to discuss about its use by government, by law enforcement. I've actually covered that. If you go to my website, markn.ca, my regular tech column where I do here in Canada for I have a local radio program that I work with, as well as the local news outlets. We've covered it a ton. It's absolutely important. But one of the critical things that's missed in most of these tests is this confidence level. You absolutely need to understand your sort of risk tolerance or your error tolerance here. If we just want to figure out like, hey, what's kind of in this image? This is great. This is fine. Anything over, 90 something or 85 something is normally good enough. If you're trying to actually recognize somebody and then, take legal action, this should be 99 or 98 or higher. There's actually guidelines published by Recognition on it. But back to the issue at hand here. So this has found a person, great. This has found a crowd. So if we look, it's identified, didn't box it, but it's identified the background as a crowd. Then all these little people here. This is pretty accurate, right? It thinks there's a building in here, which we know there is on the edge and in the background. Skin is kind of creepy, but it's found skin. And if we go down, you'll see actually this is where it gets really interesting. 81% confident that this is a festival, right? So it's got the attributes of a festival, and it looks very festival-y. There's tents in the background. There's a ton of people outside. There's the inevitable smoke and fog. It's 75.7% confident that this is actually a concert. Again, I believe it's a concert, right? It's 67.1% confident that it's a rock concert. Now that's really, really interesting because it's making I don't want to say judgment, but the easiest way to convey it is that it's a judgment based on other images that it's scanned. And it says this one is very similar to ones it knows are rock concerts, but it's not super sure, right? So 67%, it's enough. But this is recognition. So if we take another photo, let's take another photo here and show you the difference. So this one's a little more interesting. This is from Klara Kulkova, again from Unsplash. And this is, a person in silhouette using a smartphone to take a picture of blinds with this really cool gradient. But there's also a building in the screen on the smartphone. So if we drag this image over, let's see what it comes up with now. So it's analyzing, and here we go. So it says there's a person, yes, okay. Human, great. I hope if there's a person, there's a human. Photographer, so it assumes because this person is taking a photo, it's made that connection that it's a photographer. Photography as a subject, but it's less confident. Photo and electronics. So if we scroll down, there's actually a camera at 55.1%. So far less results because there's less going on, and also lower confidence ratings here because it's not quite sure, right? And this was a hard photo. Now the last one I want to do is this one. So very similar again, somebody taking a photo, but it should be a higher confidence level because we've got straight onto the person, they're not in silhouette. We've got a actual traditional camera as opposed to a smartphone. So let's drag this one over and see what's going on. Oh, image can't be larger than, come on. All right, let me squash this image down real quick. But you see, as we're doing this, you see the difference, right? Is that you're giving it, so transactional service, we're giving it a photo, it's giving us back results. We're doing it through the web browser, but we could very easily do this through, I'm actually going to have to shrink this. We could very easily do this through the API, right? The API is a very simple call. You simply send the photo up and it sends you back a block of results. So here we've done with that photo, and you'll see we have person, human, helmet. So we know this is wrong. It's 98.2% confident, but this is actually incorrect. That's not a helmet, that's a hat. So machine learning is not always perfect, even if it does have this really, really high confidence rating, right? This is not correct. But it's found clothing, apparel, electronics, camera, photographer, photography, right? So it's found very similar things, finger, face, and portrait. So it's very spot on except for the helmet, because the kids these days, you don't bend the brims anymore, right? So it thinks this is a helmet instead of a hat. So even with high confidence levels, you need to take that into account if you're using this in a project. Because if you said, hey, 98%, that's solid, I'm done, it's still not a guarantee. But this is recognition. Spelled horribly, fantastically useful. This is just the straight up use of saying what's in an image. You can use it to moderate images to make sure there's nothing sensitive being shown. And sensitive is defined by you. So you can say, you know what? I don't want any humans in my images. So if you're running a service for landscapes, you could run every image through recognition and say, I don't want any people. You could do facial analysis. You could do celebrity recognition, which is really interesting, face comparison, and then it ties into text. It also does video, which is essentially just a series of images, so it shouldn't be shocking to anybody that video is there. So that's recognition. That's one of our transactional level services. That's where we give it an image and it gives us back results. So let's take a look at something else, something different. So this is Amazon Polly. Amazon Polly, very, very simple and straightforward. You give it text, it gives you back sound. Now, I forgot to pre-install the system audio driver for my streaming software, so you guys won't be able to hear this, but you can see you can actually download the MP3. So if you just hit this listen to speech.
Hi, my name is Joey. I will read any text you type here.
Actually, let me readjust the shotgun mic, and let's play that again. Old school.
Hi, my name is Joey. I will read any text you type here.
So you might have heard that. Hopefully you did. If not, you can download this into an MP3. The interesting thing here is that Polly, that was very robotic, but Polly really has some good human utterances in to make it seem like it's better than just a robot. If you guys are old enough, you might remember Dr. Spatzo from way back in the day when Sound Blaster first came out. Very, very crazy. But text-to-speech is handy if you're doing audio stuff, so this is part of the Alexa backend stuff. But you can use it in your own. So if you're creating like a kiosk display, if you have a project where you want to provide accessibility, AWS themselves actually use this on their blog. If you go to the AWS blog, which is insanely busy this week, by the way, because there's just so much going on. But if you click here, this was a fantastic one by Jeff Barr. He did 15 years of blogging for AWS, which is awesome. Jeff's such a great guy. Every blog post they have has this little playlist, which is actually voiced by Polly. So this will read the blog post to you, and they use this through Polly as a service. Very simple, very straightforward. You might find uses for it on your own, which is great. So that's Polly. Think Polly want a cracker, and you can pick your voices, right? They have a number of female, a number of male. Very, very cool stuff. And again, that's in the transactional set of services. And let's look here. We got a couple more minutes before we hit our thing. Let's look at Transcribe. So Transcribe now is the opposite of Polly. You give it voice, it's going to give you text. So I use this for, I actually use Google's version for the most part because it had delivered some timing things that I needed, but I have a script that uses this as well to build out my blog. So when you saw this summary of when I did AWS Compute, machine-generated transcription follows. This is all generated by all the text I'm highlighting was done by a web service. In that case, it was Google's text or speech to text. And I gave it the video, just like today after I finish this, I'll give it the recording of this stream and it will spit out this text. So that's very, very useful. And Transcribe actually takes legitimate streaming. So if I start clicking on this, now you should start seeing this pop through if it will share my microphone. Now you'll see there's some errors in here, but it is very, very good first sweep. I find it's around 95% effective. So if you're looking to create content, this can be really, really good. If people aren't happy or comfortable writing, you can just get them to hold their smartphone, record themselves either on a video or as just straight voice, send it to Transcribe, and you are going to be able to get the text back. And then you can lightly edit the text and you're off to the races. I just stopped that because it was going double. But Amazon Transcribe, very, very simple. You can queue up jobs in all these services as well. If you have more volume. So for Transcribe, this is just a demo. You're just seeing the demos in the browser. They all have an API behind them. Transcribe can do real time like you just saw, or you can just send it a file, which is great. It can be a little picky on what it wants as far as format. But insanely useful, very, very useful in a corporate setting to try to get more content out. Great way. People are normally way more comfortable talking than they are writing stuff out, and then you can just use an editor to clean this up. Last one in the transactional service I want to show you. I'm not going to go through this, but I just wanted to give you an idea of what Lex is capable of, and this is just a straight up intro sort of demo for Lex. So you get to create your own bot, and essentially what you do is you map out the flow, and Lex can do it in text, is that they respond to utterances based on an intent. So in this case, you can see there's a workflow for booking a hotel. So the user says, I'd like to book a hotel, and they either do that by typing it or speaking it, because we know if they speak it, we can transcribe it into text automatically, and that's what Lex does in the background. Lex then replies in the light blue here, sure, which city, right? And then the user responds to that utterance saying, okay, well, New York. So New York is now an input for Lex to do some searching, but Lex wants more info, so it says, well, what date do you want to check in? And that's the second piece they need to do that search, and then they fulfill that search by going, okay, we are going to look for New York City, November 30th, and then we'll go through. You can do the same thing that you see that with if you order flowers, if you schedule an appointment, and this can work purely as a chatbot online, so you could hook it up to like Facebook Messenger, you could have it running on Twitter, you could do it on a number of these services, or just raw on your website, or you could have it running on a phone. You could have it answer and use it purely in audio or a mix thereof. That's Lex. It manages those transactions, and essentially think like Amazon Alexa. Lex lets you build it into your own stuff, which is very, very cool. Even though it's not Alexa, it's the tech that powers Alexa. So I know we're running a little long here, but that's okay. I just wanted to show you this last thing here before we give you some tips and tricks for reInvent next week. Aws Deep Racer, you do not actually need the car to do Deep Racer. You can get a car. I think they're $200 or $300 on Amazon.com US to get that, and you can get one shipped in. Very, very cool. But you can actually do it online, and essentially what it is this flow. So it's designed to help teach you reinforcement learning. You create a model. They have a default set model for you. You train that model, you evaluate it, and then you kind of adjust. And model is a really fancy term in this case for essentially giving it a score. So you say, try to change these variables, like turn the wheels a little bit, or like accelerate or brake, whatever the case may be. But you don't tell it those commands. What you do is you give it a goal. And so if you say, if you're 5 degrees off from your next target on the track, that's a +5 or a +10, because that's really good. If you're 25 degrees away from your goal, that's a 0. If you're 40 degrees, that's a -5. So your model gives it a score for where it's sitting on the track right now. And its speed and its time over the course, right? So you give an idea of saying, hey, you are this close to your goal or overall and to the next goal, here's your score. Based on that, reinforcement learning then decides to turn the wheels or accelerate or brake to get another score in the next slice. So this model, Deep Racer, basically is a set of constant evaluations where you set up the scoring system and then the model makes choices based on that score. So it goes, hey, I did worse, I'm going to turn the wheels more. I did better. I'm going to make less of a change next time to see if that continues to increase my score. The goal of this system is to increase the score and finish the track. It's a really clever way of getting you to do this. So essentially, when you click start, you have to create a bunch of resources. These do cost money. You're going to go through some of their tutorials, and then you create a model. And you can see it's going to take about an hour and 15 to get it up and running. But the great news is there's a ton of great information in here to kind of walk you along how to do this. I mean, it can be very, very cool. And if you have a built model, you can actually race them at the AWS Summits, though, of course, we're now done for Summit Season 2019. There is one more chance at reInvent, and then the finals are at reInvent. But it's a really fascinating way. So you can see here, actually, the Deep Racer League. So you can join the warm-up league. The Championship Cup is what's coming up. So we got one more chance on Monday, and then it's the big championship during the week. Very, very cool. If you look at the standings, last time I checked, a few of my friends won some of these, which was very, very cool. But you can go through and see all these results. And I thought this was a really fantastic way to teach you about that concept of reinforcement learning, because it's kind of weird to not give instructions to something. You just have to say, do something, try something, and I'll score you. And based on those scores, try something different. And that's essentially reinforcement learning. So we covered a ton of crazy stuff today. I'm going to review that in 2 seconds, but I just wanted to say, if you are interested in this on the technical side, here's a great book. I'm going to drop the link. There. Okay, I dropped the link in the LinkedIn chat. Computational Intelligence by Eberhardt and Shih is very much a textbook. Don't get me wrong, it is a textbook. If you are into machine learning, though, it's the textbook. It's very, very cool. It covers more than just machine learning. It's basically the introductory concepts. So this would be an intro class into computational intelligence or AI. Definitely worth reading. It's one of my favorites. I say that as a nerd, and I realize as I say that how nerdy that sounds. But today we covered a lot. We looked at some of these services in depth, but essentially we have transactional services. You give it something, you get results back. You've got a bunch of building blocks if you want to dive deeper. Most of you, if you do want to dive deeper, you're just going to go to the partially managed stuff with SageMaker. But if not, if you want to play around with some real world stuff, the tutorial pieces are cool. So Deep Lens, that's what this is, or Deep Racer, which is the car. They can be a lot of fun to work with, and a great way to learn different types of machine learning in a practical way, right? So that's an overview of what's going on. Of course, this is all going to be, there's going to be a ton more stuff added next week at reInvent. So if you are at reInvent, I would strongly recommend that if you look on my main reInvent page here, there is this ultimate guide. So let me open that up. I write this every year. It gets kind of lengthy, but in a good way. So the kind folks over at A Cloud Guru, where I'm also an instructor, they are nice enough to host this. But if you'll see, this is the table of contents alone. Just all the different things for reInvent to get you on the ground. The biggest thing to know at this point is if you're going to survive, bring sneakers. Bring sneakers in your backpack every day. Have water, a battery for your phone, lip balm, maybe eye drops, and some protein or granola bars. They're long days, they're fun days, but that's absolutely critical. And if you don't have good socks and shoes, forget fashion here, folks. Just go straight up for the sneakers, because you're just going to, even so 2 years ago, I didn't leave the Venetian. And I walked 12 to 15 kilometers a day, and I never left the one property. reInvent goes across 7 different properties, which is absolutely bananas. So check that out. Again, here's the link. Let me drop that in the chat. All things reInvent. This has been a lot of fun. I really like doing this series. Thank you guys for jumping in and hanging out with me while we do these. I think it's been beneficial, hopefully for you guys. I'm going to do more of these in 2020. They're going to be a little more structured. They won't be leading up to an event. So if you have suggestions, drop them in the chat or hit me up online at marknca or by email, me at markn.ca. Happy to talk to you guys, work through this, see what you want, because obviously the audience really makes this work. The community drives this. But in the meantime, this has been a lot of fun. Thank you for joining me. If you have any questions, like I said, hit me up. And if you're in Vegas next week, ping me on Twitter. We'll see where we're around. Maybe we'll catch a drink or a beverage. But enjoy the show. If you're not coming to Vegas, though, check out online. You can register for the live streams. for online. You can watch the keynotes online, as well as all the talks get pushed, or almost all the talks get pushed onto AWS's YouTube channel within about a week or two after the event. So you're not missing out. And of course, I'll have a big summary of that on my site. So thanks a lot. Have a great day for those of you in the States. Enjoy your long weekend and happy Thanksgiving. And we'll talk to you all soon. Take care.